Hi guys, Mrs. Baxter here. Let's take a look at our units of measure and data work sample that's coming up. This unit has been a little tricky, so let's do a quick review and go over a few problems together. I'm going to work 3 problems from our math work sample, so grab a piece of paper and a pencil, follow along with me. Let's get started. We're talking metric units and US customary units in this math unit where we are looking at how to convert different units of measure. When we're talking metric, remember those are the ones that have those suffixes like milli, centa, kilo. So liters are the unit for liquids, meters for things like length, height, distance, and then for mass and weight, grams. And you can put any of those suffixes in front, milligram, kilogram, to make your metric unit. On the US customary side, those are the units that we use here in the United States. Metric, most of the other countries around the world use. That's why it's important for us to know those as well. And US customary units here in the United States, as we measure units of liquids, we're going to use things like gallons, cups, quarts, and pints. When we are measuring distance, height, or length, that's where we're talking miles, inches, feet, and yards. And then when we are doing weight or mass, ounces, tons, and pounds. So let's put this into action. Let's take a look at question 4, where we're looking at a list of unit conversions and deciding which are correct. There are 3 correct choices. So let's look at the first one. 343 meters equals 34 centimeters. Right away, I can see there's something wrong with this because centimeters are very small. Meters are much larger than centimeters. So 343 meters cannot be 34.3 centimeters. I'm going to cross this one off. Let's look at 1.25 kilometers compared to 1,250 meters. That's looking a little bit more plausible. So when I change from 1.25 kilometers into meters, I'm going from bigger kilometers to smaller meters. So I'm going to multiply. Remember, big to small means multiply. We're going to multiply times 1,000. That's our conversion factor because 1,000 meters are in 1 kilometer. That means I move that decimal point to the right 1, 2, 3 times. Fill in that empty spot with a 0, and I can see this is a correct conversion. Let's look at the next one. 1.7 centimeters equals 17 millimeters. Well, I know that there are 10 millimeters in every centimeter. And when I change from bigger to smaller, I multiply. So 1.7 centimeters does equal 17 millimeters. Okay, there's 2 of our 3. And finally, 345 millimeters equals 0.0345 meters. Well, this is looking promising. 345 millimeters. Since I'm going from a smaller to a bigger this time, I use the opposite operation. I'm going to divide by my conversion factor this time. So there are 1,000 millimeters in 1 meter. So 345 divided by 1,000. That's where I can move my decimal point to the left. 1, 2, 3 times. I put that decimal point back in. And yes, I can see here's my third correct conversion. If I look down at the bottom, 4.7 meters equals 47,000 millimeters. I can see that there's an extra 0 there without even having to multiply because there's only 1,000 millimeters in every meter. So there's no way that about 4 meters could make 47,000 millimeters. Let's take a look at number 12. Allie purchases fancy chocolate for a dessert she's making. The chocolate costs $16.50 per kilogram. If she needs 400 grams of chocolate, how much will she pay? Well, I know that I'm going to need my final answer in the cost per gram, but they gave us the original cost per kilogram. So I'm going to need to do some converting here first. There are multiple steps in this process, and you could do the steps in slightly different orders. So if the way I solve isn't the exact way you chose, that's okay. So I'm going to start by taking my $16.50 per kilogram and changing that into price per gram. Well, I know that there are 1,000 grams in every 1 kilogram. So I'm going to take this original cost and divide it by 1,000. So I'm going to move that decimal point back 3 places. Let me rewrite that a little bit more clearly. 0.165, and I'm going to drop that extra 0 because the 0 at the end is not going to change my answer. Now, this is the cost per gram. It doesn't quite look like the way we write money yet, but I'm going to leave it as is. I'll make sure by the end it is cut off at 2 decimal places. So here's the cost per gram. Allie is going to purchase 400 grams. So I'm going to write times 400, and I like to hang those zeros off the end. It helps me remember to put them down here in my answer, but lets me focus on where I need to multiply. So 4 times 5 is 20. Carry that 2. 4 times 6 plus 2 is 26. Carry the 2 again. 4 times 1 plus 2 is 6. 4 times 0, 4 times 0. A lot of zeros in my answer. I bet I'll be able to get rid of a few of them. My final step is to count my decimal places. There were 1, 2, 3, 4 digits that came after a decimal point in my original problem. That needs to match in my answer as well. So I'm going to count back 1, 2, 3, 4. Notice that's why I didn't remove my extra zeros yet, because I wanted to make sure I had all of my place values in line. Now that I have my decimal point in the right spot, I can cut off my money value at 2 decimal points, and I can get rid of these extra zeros at the front and the back. I don't need them. I can see that Allie is going to pay $6. Oh, crazy penmanship, Mrs. Baxter. $6.60 for her chocolate. Let's take a look at number 18. This one includes a line plot. This line plot is about books and its thickness in inches. So if Margot made a stack of her 4 thinnest books, how much would that pile measure? Well, the thin books are over here on this end of my line plot. And I'm going to box up those 4 X's because each X stands for 1 book. So her 4 thinnest books measure 1/2 of an inch, 1/2 of an inch, 5/8 of an inch, and 5/8 of an inch. I'm going to add all of these together because if I were to stack those books one on top of the other, I would make a total stack and I need to find their total thickness. I like to group these together and add the ones that have common denominators first. 1/2 plus 1/2 is 1 whole. 5/8 plus 5/8 is 10/8. Now that's an improper fraction. I can change that up. 8 goes into 10 one time with 2 left over, 1 and 2/8. Well, that's still able to be simplified further because I know that 2 and 8 share a common factor of 2. So that is also equivalent to 2 and 1/4. So now I'm going to put both of those separate problems together. I have my 1 whole right here plus my 1 and 1/4 gives me 2 and 1/4 altogether. I hope that was helpful, 5th grade. Reach out if you have any questions or concerns. Feel free to go back, pause the video, and take a look at any of the problems that we've worked together. Best of luck. I know you'll do great on your work sample.